this is the scope of what we're going to talk about in today's presentation. Applications, just keeping track of radiation therapy, imaging, but also tracking patient-reported patient-reported outcomes over time. So again, non-imaging data being correlated with the imaging data. And broadly, we're seeing a trend towards multimodality data and machine learning supporting really the evolution of applications to support personalized medicine. So some of the challenges there, of course, then are sort of creating a 360-degree view of the patient or the subject, combining imaging and non-imaging data together in the same system, and tools like traditional EDCs, Redcap and so on, are pretty good at capturing and building a database of clinical attributes from different systems, but don't really handle imaging, with that data very effectively. So we'll talk a little bit about how we would do that type of thing inside of Flywheel. So some of the common data types we run into are obviously the various DICOM imaging data, but also EMR, typically in the form of FHIR or HL7 based data. We see customers bringing in genomics data to correlate with imaging biomarkers and so on, EEG, histopathology, and other data types. But as a little context, for those of you who aren't aware of Flywheel, Flywheel is a research data management platform that addresses the life cycle of a research project, from capture to curate to computation on your data, and provides a secure collaborative environment for sharing data and sharing algorithms in the context of your project. So when we talk about capture, we're talking about imaging and non-imaging data, de-identification along the way. When we talk about curate, we're really talking about the heart of the Flywheel system is a metadata database that's tracking all of your data and allowing you to annotate and add custom metadata on every object. Provide powerful search, API access to all the underlying data, make it easy to work with your data. And then the compute framework that we're talking about here kind of comes in two forms. One is automated routine processing through what we call gears, plug in pipelines and applications that Flywheel can manage to, handle anything from basic pre-processing to full analytic pipelines. But we also talk in the context of compute around open APIs for, reaching in and grabbing data, performing various analyses using existing pipelines and tools, or doing exploratory development. So it's a very complete framework from that point of view. So capture, curate, compute, and then everything in Flywheel is done in the context of secure project boundaries. You can kind of think IRB scope, what would your IRB allow you to do here? So what's the authorized data? Who are the authorized participants and collaborators? What are their roles and privileges, and so on. And so Flywheel organizes its work around essentially secure projects that, implement, essentially IRB constraints in many ways. We started in imaging core facilities, managing data coming off the scanner, automating the entire workflow. So we, a lot of our customers do classic imaging research. Increasingly, because of the curation workflows associated with machine learning, Flywheel is doing a lot of machine learning projects. And because we're web-based and easy to use, we're very well suited for multi-center studies, and collecting data from multiple sites and allowing people to collaborate across those sites. And the system, can be deployed in the cloud or can be deployed on-prem. Basically, half of our customers are in the cloud and half are in on-prem deployments. And we support academic, clinical, and life sciences customers. So I won't go back through all of this again. I've described a lot of this, but it's essentially a complete end-to-end workflow for research. A lot of what's behind our customers' interest in Flywheel is getting, maximizing the value of their data, the ability to reuse it, to share it, to collaborate on it. And if you think in terms of NIH FAIR, it's a great way to think of Flywheel. It's we're making your data findable through metadata and search. We're making it accessible through open APIs and tools, interoperable through standards, include imaging and non-imaging standards, and then a key driver for Flywheel is the idea of reuse and sharing, both of data and algorithms. Really behind the scenes, we're thinking all the time about scientific reproducibility. So you want to have all the data and all the algorithms, in your project so that you can essentially reproduce your project end to end. Now, let's talk about a few quick workflows, and then the multimodality approach will make some sense. So multi-center collaboration. And this is an example of a Down syndrome project where UC Irvine's the data core, Columbia and MGH contribute data. They all work together to contribute the data to, process and quality control the data, and ultimately that data is delivered to the NIH. And this project has actually expanded well beyond what it was originally intended. Mike Yassa at UC Irvine has brought in all of his historical data and has created a collaborative at UC Irvine around Flywheel, in addition to this multi-center project. Another classic example of Flywheel is where we really started in imaging core facilities, capturing the data off the magnets in a MRI imaging center, bringing in potentially data from the PACS or the VNA, other modalities like OCT and so on, and then using Flywheel as the framework for delivering the data, but also allowing the labs to collaborate and share information through secure projects to collaborate effectively, both inside the building and outside the building. So about half of our customers are actually this kind of model, using us as a framework for managing core facilities. We're seeing a lot of growth in clinical research, and this is where the multimodality piece starts to really kick in for Flywheel. Is not only are we doing imaging work in this clinical research context, but they're correlating data with EMR data, digital pathology, data from Redcap, bringing that together, essentially saying, look, we as a health system with a med school have a wealth of data here if we can only get it in the hands of users securely, while dealing with data privacy and doing all of that in a very cost-effective way. So we have a number of customers using us in this fashion, make clinical data available to their research communities. And again, it's imaging research, it's machine learning, increasingly translational testing around personalized care applications. And then very quickly, this is an example of largely multimodality as well, a very large pharma using us as a platform for their strategic AI and personalized care development. So it's many types of imaging and related data being ingested from their CROs, their historical projects, being pulled in, curated in Flywheel, and then they can select from that pool of data, that data lake in some sense, and create new projects for downstream R&D initiatives and further process it, maybe generating new biomarkers or synthetic controls, that type of thing. So this is a very large system approaching millions of data sets, using Flywheel. So these are the types of things people do with Flywheel. So let's talk about multimodality research, in Flywheel. So to kind of set the stage, you kind of in Flywheel, to think in terms of multimodality, you've got to think about sort of 4 levels of functionality. One is, how do I deal with the file types that I'm ingesting that represent the various data types, of course. Then there's a layer on that, is what do we do with the metadata from that? So in the classic case of DICOM, we're extracting the DICOM tags and indexing that information in the Flywheel database, but many other types of complex objects exist and have their own metadata. So it could be, the header file for some EEG data. We'll talk about that as an example in a minute. So how do you manage metadata in Flywheel? How do you attach that metadata, make it indexable, searchable, accessible through the APIs? And then you have the issue of, do I need a viewer for that data? So in the case of imaging data, many forms of DICOM and so on, we have built-in viewers for, commonly used DICOM types and NIFTY and things like that. But if you have a new data type, what can you build your own viewer? Can you how do you accommodate that? And we'll talk about how Flywheel addresses that. And then finally, can I analyze that data? So we have many different algorithms you'll see for processing images, free surfer gears and FSL gears and, various quality control gears and things like that can be applied to your imaging data. But what happens if you bring in EEG data or digital pathology data. How can you analyze that data? So we have a whole framework for dealing with all of these issues in a very open and extensible way in Flywheel. And that's really what I'm going to emphasize in the rest of this presentation. So first off, Flywheel does support multimodality imaging. So here's a number of examples ranging from, CT and PET and X-ray and cardiac imaging and MR, that kind of thing. So we have a broad, range of support for DICOM and the related raw data. And that's a, kind of a classic strength of the Flywheel platform, and the reason why many people would consider Flywheel in the first place. And the imaging is probably a big differentiator in the ability to support the multimodality imaging. But again, we're not limited to imaging. So, as an example here, we have a experience with a broad set of imaging data types on the left, all the major vendors, all the major formats. But we also have a lot of experience with non-imaging data. And that's really because we designed the system from the ground up to be, kind of focused on handling complex objects and including imaging, but we designed it to really be able to handle any file-based data. And as an example, or just as a framework, we have a system for data type extensibility so that we can handle this type of multimodality research. So the first issue, of course, is can we ingest the files? And the answer is yes, we can handle any file-based data. Then the issue is, do we have a framework for handling the metadata, indexing it, making it searchable, making it more accessible? And we have an extensible custom metadata framework. And then the third part is adding the viewers, for those data types that we don't have built-in viewers for. So an example of how we accommodated EEG, was using the Brain Vision EEG data set. So these data sets actually consist of 3 files, a header that has all the kind of channel information and that sort of details. Then you have the actual data, the underlying values, and then you have marker files that indicate the key events. And that package of 3 related files actually is the complete EEG data set. So in order to handle this in Flywheel, we ingest that set of files, and we then go about extracting the metadata. So we use our Gears framework, our automated, these plug-in modules that I described earlier, and we created a gear that extracts the metadata and adds it as custom metadata at the acquisition level associated with those 3 files, and do a search and say, find everybody who's had a 22 channel Brain Vision EEG, with certain parameters, if you like. And then to go further, we added a custom viewer using our Open Viewer plugin API, or we'll call the Extensions API. And we created a waveform viewer that can be opened, just by pointing at those underlying EEG files. So this is a kind of an example of what happens when we introduce a new data set. Depending on the data type, there's some choices to be made, but the main point is, see a new data type, we have a framework for capturing the metadata, introducing new viewers, and managing that data systematically in Flywheel. Just a little more expansion on the viewers, the viewer plugin concept. We have integrated viewers for many data types in the system, but if you need to add your own, you can. And it's done through this Extensions API, and that can be as complex as the waveform viewer I showed for the EEG. It could be a new object viewer for OBJ files or whatever type of particular files you have. But it could also be as simple as creating forms for something like patient-reported outcomes. And the nice thing about this is you can think of it as a tool for building viewers for file types, but you can also add custom viewers and pages in the Flywheel user interface to accommodate new views of any level of the Flywheel hierarchy. So that could be at a file level for data viewing, but it could also be a new subject viewer that maybe does a longitudinal time point analysis across the lifetime of that subject, or a project level dashboard that essentially summarizes your cohort, or even does project management, extensions for Flywheel. So this viewers extension API is actually really powerful, not only handling new data types like in the multimodality case, but you can also really extend the user interface to be customized to the needs of any given project. So let's talk a little bit about how we accommodate new data types. So I've kind of described the general framework, but really what's happening underneath the sheets in Flywheel is there's the concept of groups, which would normally be your labs, your virtual teams, maybe a clinical trial, a set of related sub-projects. You can use groups to organize a set of related projects. Then you have projects that are exactly what you'd think, typically a grant-funded study, or maybe representing a site contributing data in a multi-center study, that type of thing. Each of those projects then have some number of subjects, and then the projects can be longitudinal in nature, so a subject can have as many time point exams as needed. So we call those sessions, maybe a little bit of our imaging bias there. And sessions, those time point exams, can be made up of any combination of data: imaging, non-imaging, multi-modality, multiple modalities of imaging, whatever it needs to be to represent the scope of that time point exam. And the way all this works is, if you look on the left here, there's every one of the levels of that hierarchy can have files attached and can also have custom metadata attached to the object in the database. And in fact, we can track analyses that we've performed against those objects and document that. How do we analyze it? What were the inputs and outputs and configuration options used, that sort of thing. But in terms of the multimodality part of the story, we can attach any file to any level, and we can capture the metadata or add and represent external data as metadata and make that available in the database for access and make it all searchable. So there's a kind of an extensible framework of metadata here in Flywheel that allows you to kind of immediately get some consistent structure out of the Flywheel system, but also offers, extensible functionality so you can tailor the system to meet the needs of your unique project. And everything's tracked, and there's access controls and ways to automate things and so on that we can touch on later. So let's look at some simple examples. So we've created the OHIF viewer for DICOM. We've contributed to the open source environment there and contributed the Nifty viewer and other components, including integration of some very powerful image annotation tools for drawing ROIs and capturing the results. And so we participate in OHIF as a contributor to that open source initiative. And then the OHIF viewer is integrated fully into Flywheel. So essentially you have radiology grade tools right in Flywheel. So a common use case is image annotation for machine learning studies. Maybe you're doing blind multi-reader studies, and Flywheel would present a work list, allow the reader to go in, draw annotations, and save those. Now, the way we implemented this to capture the underlying data is, again, using that extensible metadata structure. So if you look on the right here, you'll see essentially this is all the underlying data for each of the ROIs that the user would draw. So at the end of the day, it makes it accessible through an API, very easy to access and analyze. The search engine, for example, can use this information to find, for example, all subjects that have a lesion larger than X, and do a match on the ROIs in the context of search. So that's one example of using the custom metadata that I described. But if we keep going in the context again of multimodality research, how might we use this idea? So one common example is integrating Flywheel with Redcap. So Redcap databases are often created for clinical trials or other studies, but Redcap fundamentally doesn't support imaging. And so oftentimes our customers are very interested in imaging. So how can we link these two systems? So we make that very easy. So first off, we have the extensible metadata that I've described on the left, can be at the subject level, the session level, whatever is appropriate, project level, if you want to capture, IRB constraints or that kind of thing. But how do you get your Redcap data synchronized with Flywheel data? So it can actually go both ways, if you like. You can send biomarker data from your images into the Redcap database, but oftentimes what customers want to do is pull in the data from the Redcap database and make it available in the database along with the imaging data, and have a common search space and a common metadata space for analysis and so on. So we make that very easy to do. We have the custom metadata, we have Python APIs, for example, to Flywheel. We have MATLAB, we have R, other APIs. But we typically would sync up using a library called PyCap for Redcap, and then pull the data from Redcap, use the SDK in Flywheel to write the data to the appropriate levels of the hierarchy, and it's saved as custom metadata, just like I showed the ROI. So then at that point, it's available to any user in the Flywheel system. So Redcap integration is a common use case. Another example would be importing EMR data into your Flywheel project. So the most common way these days, I think, to do this would be using FHIR, which is sort of the modern extensions of HL7 to represent EMR data. And in this case, what we've done is we've imported an entire patient bundle and attached it to the subject, the patient in this case. So on the left here, you see, this FHIR record has a set of care plans, a care team, claims, conditions, encounters, observations, the various practitioners, really everything about that patient's history. Now, you could, of course, select to import only the things like, let's say, observations and encounters that make sense for your conditions, depending on the nature of your research. But in this case, we've imported the entire bundle and attached it to the subject. And kind of on the right here, what you see is, I think I've opened up a specific observation, so you can say, well, here's some vital signs data that you want to be able to access and correlate with your imaging. And so Flywheel can easily import a Flywheel bundle. Fundamentally, our custom metadata is JSON-based. FHIR is JSON-based. We can attach those objects, and at that point, they're searchable and accessible via APIs for analysis and so on. So that's a general overview of one way we can approach EMR data. There are other ways to do it, saving the data as files and so on. But in this case, we've chosen to go the attached metadata route, and that is and our goal is to build out a more standardized library of tools to support EMR integration, so it kind of works right out of the box, much like the standard imaging works. Another example is digital pathology data. We have customers who are starting to import digital path data from a variety of sources. And if you're familiar with this, there's many different vendors and file formats, but increasingly there's interest in making those files part of the DICOM standard. And so what we're doing is providing Gears plugins that, we can load those original vendor-specific files in Flywheel anyway. But what we're starting to do is build out a library of Gears that can convert those data to DICOM, so that they can be viewed in the viewers and annotated in the same way that the standard DICOM images are. And then, of course, you can apply pipelines to them as well. And then where there's metadata involved in these source systems, we can also attach it just like we would the DICOM metadata and make it all searchable from there. So essentially, you could, in an oncology project, for example, you can incorporate your digital pathology data and correlate it with your traditional imaging data. Genomics is another example. So here we've got an example of some test genomics data, but basically we have the ability to manage the VCF files and the BAM files and the typical genomic sequence files, and carry that around in your patient or subject records along with your imaging, EEG, other data types. And while Flywheel is not really going to do a lot with that particular data type natively inside Flywheel, we have built interfaces to Google's BigQuery and Life Sciences API. You could certainly access that data from scalable analytic environments like Spark and R, some variants that are now developing in the Python world, Amazon Redshift, and so on and so forth, and bring your biomarker data, your metadata, your genomic data, and then Flywheel's managing that core data. You go off, you do your analytics, and you pull back your results and and store that back in Flywheel. So that's one way we would handle genomic data along with your imaging. And then finally, forms and survey data. I mentioned this patient-reported outcomes example earlier. You could build a custom form, attach the metadata to an exam, in this case, a session. Similarly, you could have a cognitive exam or some other survey or form-based data that gets saved on the subject. And again, it's all available in the same way now that your DICOM data, your digital path data, your EMR data. So it creates a common database and a common structure, so then you can perform your various analyses. So those are some examples of how we would handle certain data types, and Flywheel provides a variety of tools for getting those data types in. You can do simple drag and drop web uploading. There's command line tools and scripting for loading larger volumes of data. And where appropriate, we have a DICOM connector and a file system connector associated with it that can monitor for new data showing up in certain locations and pick that up and move it along. De-identification can be applied, and the data ends up in your Flywheel system. And then our processing framework, while we emphasize image processing traditionally, running FreeSurfer, MRI-QC, FSL, SPM, ANTS, MR-Trix, all those types of algorithms, the human connectome pipelines as gears. That same framework can be extended to process any file types. So we provide tools that allow the users to, our customers to build their own gears. Essentially, a gear is just an OCI compliant. If you're familiar with Docker or Singularity, those are Open Container Initiative compliant containers, and you get your code running in a standard container, and then you provide a little additional metadata that explains to Flywheel how to run it, either by rule, setting up some automation rules, running it in batch or running it on demand. And then Flywheel will, direct that workload to the appropriate system for processing and then track the results and so on. And one big advantage of Flywheel in a context like this is that we have elastic scaling. So if you need to run, 1,000 FreeSurfer jobs, we can, largely scale all that up in parallel. And likewise, that could be used against genomics data or, schedule a machine learning training run, or, handle your multimodality data just like you would your traditional imaging data. And then we share these things. So where you should expect to see Flywheel go is we have a rich library of close to 100 algorithms that are out there, ready for use, largely around imaging, but we're starting to introduce digital pathology and EMR and other algorithms into this library. We expect to build out a broad set of functionality across a broad set of data types. But we share all of our work as open source there, and our customers are beginning to share their work with the community as well. So, for example, Dr. Matt Sislak at University of Pennsylvania recently introduced a new diffusion pipeline developed as a gear, and this example here is Ted Satterthwaite at Penn also has developed a new XCP engine and shared it through the Gear Exchange. So anyway, so we, we're creating an extensible system, a place to exchange those extensible components, processing components, data type handlers, that sort of thing, and we share those. And then if you don't want to process your data inside of Flywheel, but we still add value. The fact is we can make it very easy for you to access all of your data in one place, pull it down, do your various analysis, but Flywheel will provide a data management framework for you to manage and track all of your activity against those multi-modality data sets. So whether you like to do routine processing using our Gears framework, or whether you want to just manage the data and pull it down to your favorite tool, whether that's Python, MATLAB, or R, or other, we make that easy for you to do as well. So that's that's the main gist of the presentation today. I hope that was useful. For those of you who are familiar with Flywheel, you may not be familiar with the non-imaging aspects, and that was our goal today, is to emphasize that we can in fact do those things and are doing them. And we're starting to win various COVID projects in the current circumstances, and many of those are multimodality in nature. So people looking at the long-term impact of the brain and cardiac and correlating with EMR and related data, but there are many other use cases for multimodality. So we thought we would share what we're doing. And in the context of ISMRM, MR data is important in the COVID research context. So we thought it'd be a good time to emphasize the multimodality aspects of Flywheel in that context. So that's what I have for the presentation today. Happy to take any questions.
Travis, could you cover what skills would be required for building gears to create a processing pipeline?
Sure. So gears, again, are really just a standard open container initiative compliant unit of code. So if you think about, from a scientific reproducibility point of view, the one thing you want to have is an application that's always going to run the same way every time. So it has its code, it has its dependencies, everything locked down so that version 1 of that algorithm always runs exactly the same way and can be fully reproduced. So the OCI, the container concept is a way to do that. You put all your code and dependencies in a container and lock down that image, and then it becomes portable. And then Flywheel, in this case, can scale up, and run as many copies of those portable containers wherever they need to run to process, each piece of data. So that's how it actually works. So in terms of building it, it's really a very standard set of technologies that pretty much any developer these days should really know how to do. To build a Docker container, for example, you typically use the Docker tool set to do it. And the first trick is to get your application and all of its dependencies into a Docker container and test that container executes your algorithm successfully, typically by taking one or more input files, performing some processing, and producing some set of output files. And once you've got that running, basically your algorithm works. Then it's a fairly simple process for a developer to add some additional metadata that describes to Flywheel how that container should be used. In other words, what data needs to be moved into the container to processing, what command or commands to execute, and then how to pick up the results and move it back to Flywheel. And the metadata also includes some descriptive information so that when you register the algorithm in the Flywheel system, you can search for them, you can read about it, you can find the link to the source code, all that type of descriptive metadata is also in the container itself. So it's a portable self-describing package based on standards that can then be registered with your system. And by the way, if you don't want to share your algorithm, you can just keep it on your own Flywheel system and no one other than you and your team will see it. But if you did want to share it, we make it, we have a tool for that, which is called the Flywheel Gear Exchange, and you can share that with other Flywheel users more broadly in the community. But skill set wise, it's standard development, fairly straightforward. We offer full training and videos and webinars and so on how to do that. So if you are or have on your team a scientific computing resource, then anybody familiar with pipelines and processing would easily be able to build gears.
And then you touched on it a little bit in the presentation of building any custom viewer for any of this data. What's involved in that process for imaging data types and non-imaging data types?
Sure. So it's really pretty much the same kind of thing. In the viewer case, or in the algorithm case, I described this concept of containers, and that's kind of more back-end processing, the way a lot of people would think of it. It kind of runs on the server. So you tend to use a different tool set, but Flywheel, it's a way to standardize that unit of activity. In the case of viewers, you're building typically a Flywheel's orientation is browser-based to start with. So our goal is typically to allow you to have a zero footprint or a browser-based user experience for whatever you're doing. And so the Flywheel user interface is web-based, and underneath the hood is based on JavaScript and some related libraries. So we offer a similar kind of extension for building your own user interface components and viewers. So essentially what it is an API, a JavaScript API that you can embed in a viewer or other application, and you put that application in you host it somewhere. It could be in GitHub or a CDN of some sort, and you register that application with Flywheel, and then Flywheel, based on what level of the system you've linked it to. So if you've linked it to a new file type, for example, whenever you go to hit the viewer button on that file type, it will automatically launch your application. But it's developed in JavaScript. It's just kind of linked and registered to the Flywheel system. And Flywheel, through the API that I described, automates the security linkage between your custom app or custom component viewer with the Flywheel system. So when the application wakes up, it will be handed the context. For example, I've just pointed at this file, I would like to view it, and you'll be in a security context so that it'll know you're authenticated and you have access to that data. So it's a secure framework, but it's pretty much anything you can do in industry standard JavaScript or related tools, like D3 or other visualization tools that you might choose to use in that context. But ultimately, it's a simple web application. So anybody who can essentially build a visualization or a viewer can easily create a custom component in Flywheel using this extensions API. And that could be as simple as forms too, by the way. It doesn't even have to be complicated. It could just be, I want to build a project management interface to my Flywheel project, and you could simply build a set of forms that manage those aspects for you and plug them right in, and it'll look like a native part of Flywheel at that point.